All right, so this video is going to be on pages 6 and 7. So we're going to start with number 1. It says, what are the 3 methods by which energy transfer can occur? So first one we have is conduction. Okay, so that is the transfer of basically energy through touch. Okay, and then you have convection. Okay, so that is like the transfer of energy through a medium like air or a liquid, so like holding your hand above a hot pot. Okay, and then you have radiation. So that is something that's like coming from the sun itself. Okay, number 2, it says define a wave. So that is the transfer of energy through a medium. Okay, now that can be a material medium. Okay, so like water, air, okay, or space. Okay, so space would be, you didn't need anything. Okay, but it has to be some type of medium. So 3, what are the 2 categories of waves and how do you differentiate them? So first you have your electromagnetic waves, so your EMR waves. Okay, and those do not need a material, so don't need a material medium. Okay, so that would be like your space. Okay, so they could travel through space. They don't need anything to actually move on. Okay, versus mechanical. Okay, those do need a material. Okay, they need something to actually transfer that energy to. So they need some type of particle, okay, whether it be air, water, rope, spring, any of that stuff. Okay, number 4, give 3 examples of each category. Okay, so let's do mechanical. Okay, so mechanical be something like a water wave, a sound wave, okay, or a spring. Okay, and then EMR would basically be anything on the EMR list that I told you on the last video. Okay, so that could be like radio, light, X-ray, okay, anything that does not need that medium. Okay, number 5, what are the 3 types of mechanical waves and how do you differentiate? Okay, so number 1 would be transverse. Okay, transverse looks like basically this. Okay, it's where the direction of the wave is going up and down. Okay, but the actual movement is going left to right. Okay, so your direction of the wave and, the movement of the wave and the direction are perpendicular. That is what a transverse is. Okay, versus a longitudinal. Okay, that is like your compression wave. Okay, so that is like when you have a spring. Okay, so you have it stretched out and then it starts to compress and then it starts to stretch back out again. Okay, so the direction of the wave is going left to right. Okay, but also the actual movement of the wave is going left to right as well. So they're going parallel with each other. Okay, so that is a longitudinal wave. Versus a surface wave. Okay, that is like the surface of water. Okay, you have both longitudinal going down and up, and you also have a transverse going left to right. So surface is just a combination of both. So combo of both. Label each example of heat transfer as either conduction, convection, or radiation. So we are just labeling each one. Okay, so 1 says the reason why a wooden spoon stays relatively cool even if it's in a hot pot of soup, but a metal spoon sitting in the pot will get too hot to touch. Okay, so it's actually sitting in the pot being heated up, so it's actually touching something, so this would be conduction. Okay, so the reason why is a wooden spoon is a poor conductor of heat versus metal is actually a great conductor of heat. So all that energy is able to transfer more into the metal spoon. Number 2, a hot air rises and cool air from the surrounding areas rushes to replace it. So this is convection. So this is like when heat rises. Number 3, the heat that you feel from a filament of a light bulb when it is turned on. Okay, so this is called radiation. Okay, so you're feeling that heat from the light, so it's going in all directions. Number 4, fiberglass insulation in a house's wall to prevent this. Okay, so the reason why we do that is you want to block out convection. Okay, you want to block that basically transfer of cool or hot air from the outside. Okay, so if it is cold outside, the last thing you want is that cold making its way inside. So that is what insulation does, is it stops that convection. Number 5, the heat that you feel when you are across the room from your fireplace due to this. Now, this one can be a mixture of both convection and radiation. Okay, so convection would be more if you put your hand on top of the fire. Okay, you could feel the air heat rising. Okay, but this one said across the room, so this is going to be more on the radiation side. Okay, so radiation is a heat that basically goes in all directions, so it's being emitted by the light, okay, of the fire. Okay, so this is a reason why is if you turn sideways to a fire and the left side, we'll just pick the left side of your face gets hot and the right side of your face doesn't, okay, because that radiation can only travel in a straight line. So that left side of the face takes all the radiation and the right side is in the dark, okay, so therefore it does not heat up at all. Okay, so that one's going to be more on the radiation side. 6, the reason why a metal doorknob at 50 degrees Fahrenheit feels colder than a wooden door at 50 degrees, okay, same temperature. Okay, so this has to do with touch, so that is conduction. Okay, so moving on to the next one. The driving force behind the formation of storms and clouds. So this is the driving force of heat or cold, okay, of an air. Okay, so it's basically through a medium, like you basically have clouds, which are basically liquid, okay, in the air. So this is going to be convection. Number 8, the reason why concrete sidewalk at 60 feels colder than carpet floor at 60. So again, this is about touch, so this will be conduction. Number 9, the heat you feel from the metal on the stove when it glows orange hot. Okay, so we're not touching the heat. Okay, we're just holding our hands around it, so this would be radiation. Now, you could also kind of say this is a convection if you hold your hand above it just from the heat rising. Okay, so it could be honestly kind of both. Okay, but that radiation means you can feel that heat no matter where you put your hand. B, the way that the water warms up on the stove before it starts to boil. Okay, so it's actually the pot is actually touching the stove, so this is going to be conduction. Okay, so it's direct heat transfer from touch. Now, when the hot water at the bottom of the pot begins to rise up to the top, while the cooler water at the side falls down, okay, this is going to be that convection. It is that transfer of heat through a liquid. Okay, so that'll end that video, and we'll start on page 8 on the next one.